lab notebook, right? So I know I said bring your lecture notebook and your lab notebook, but I think just for now, open up your lab notebook. And there's a series of PowerPoint slides we're actually going to go through, okay, but they won't take very long, I don't think. Yeah, so can you find a slide that looks like this in your lab notebook? Not your lab, but your lab notebook.
What experiment is it?
Yeah, your finger. Ionic. This one, So kind of look through there. Right there. Everybody put your finger on it so I know you got it. No, I'm just kidding. Looks good. Thank you. All right. So we're going to focus on, two types of compounds, molecular compounds and ionic compounds. We're just focusing on ionic compounds. You guys are going to make them and you're going to name them. So there's power in a name, right? So the thing about ionic compounds is basically electrons are transferred, right? And electrons are transferred to give both atoms a complete octet, and we've been talking about that in class. And the electrons that are most important are those valence electrons. So this slide just kind of reminds you that. And so we said that metals lose electrons. Metals are great at losing electrons, and they form cations, okay? And they get that rare gas configuration. Basically, they become like the rare gas in the period before them because they lost electrons. Okay, and nonmetals pick up a few electrons and they become like the rare gas at the end of their row. Okay, so they get complete octets. And then in lecture, we focused a lot on monoatomic ions, okay, where it's just one atom that's losing an electron or two, or one atom that's gaining electrons or two, right? But actually here today, we're going to talk about those first, and then we're going to build up. It's in 3 parts, today's lab. The third part of today's lab, we're going to talk about those polyatomic ions, like nitrate, sulfate, chlorate, chloride, all of those that have more than one atom. They're stuck together, and the cool thing about it is those atoms are stuck together with covalent bonds, but they are running around with a net charge. Okay, either they have extra electrons, so they're negative, or they're electron deficient, so they're positive. Polyatomic ions. Okay, so we talked about if it's a monoatomic ion, well, even if it's an ion that has more than one atom that are stuck together, okay, we have positively charged cations and negatively charged anions. But you're good with that. Okay, and we talked about this is where I'll go ahead and remind you. Actually, if you have a periodic table, one of the things of our 3 sections, we're going to focus a lot on the group A elements for section number 1. So if this is 1A, 2A, and then we have the B elements, and we have 3A, 4A, 5A. Oops, that's an A. Okay, anyway, above the 1A, you probably put a +1 charge in lecture. Okay, that means it forms a +1 cation. Above the 2A metals, you probably put a +2. So I'm counting on you, everything that we talked about in lecture. Those will all form a +2. Wish we had a periodic table in here. I need to work on that. There's room. I just need to get one. Okay. The 3A metals now. Remember, you have to skip boron and then start with aluminum. Okay. They form a +3 charge. Okay. And I say you can hang your hat on what those form. Okay. You know what they form. That's not always the case with metals. Okay, so here we go, the 1A, 2A, and 3A. All right, so then with the nonmetals, kind of starting with the halogens, the 7A, I'll just kind of remind you how this goes. Of course, 8A, they aren't reactive, right? So they don't form ions. But the 7A form a -1. The 6A form a -2 because they pick up 2 electrons. And the 5A nonmetals, at least nitrogen and phosphorus, form a -3 because they pick up 3 electrons. Okay, so that's the charges of those atoms on the periodic table. So here are those, just to kind of remind you what we talked about. All right, so now we're getting into something a little bit new finally. So today you're going to write the formula of ionic compounds and you're going to name them. So you're going to do both of those. And like I said, 25% of your test or so is going to be this topic. And after tomorrow, we aren't going to talk about it anymore unless, you want to talk about it, like outside class. We are going to have those Wednesday sessions, so there will be, I guess, a form of a review session right before the test, that Wednesday before the Thursday of your exam. Okay, so you guys are all, if we start with table salt, okay, table salt, right? That's the formula for table salt. It has 1 sodium, 1 chlorine that go together, okay? Those are the subscripts, they're implied. And they do this to give the same, this as I've written it, as Na1Cl1, that actually makes what we call the same number of positive and negative charges. And it looks like this. Sodium is in 1A, so it's a +1 charge. Chlorine is in 7A, so it's a -1 charge. Okay, do you see where if we have one of these and one of these, like we're saying here, that actually we have 1 times +1 plus 1 times -1, so that is, you know, neutral. There's no charge. That's kind of what we're after here when we rewrite it. So we're going to stick with ionic compounds that just have 2 things, and those, I don't think you have this slide. This slide is in your other notes. This actually is in your lecture notes. But I'll put it up tomorrow. How's that? But the word bicycle means 2 wheels, so the word binary compounds actually has that bi going for it, and just means 2 things that are stuck together. You might need more of those things to make sure it's neutral, but there are only 2 types of things that are stuck together. Okay, and you don't have this one either, but this one's in your lecture notes, and like I said, I'll kind of go through these tomorrow. But sodium is 1A, so there's the 1 valence electron around the sodium atom. Fluorine is 7A, so there's the 7 valence electrons. Okay, so we can kind of think as sodium giving up an electron, fluorine taking up an electron. Sodium, that metal, becomes a cation. Fluorine becomes an anion, and ... they have a connection there. So this is where sometimes, and I think in lecture I say I like to put the ... That's like this is my ionic bond. Oops, ionic bond. All right, so looking at another one, oops, maybe. Okay, sodium is a metal. Sodium is your cation, okay? It'll form a +1 charge. Sulfur is 6A. You can see the 6 valence electrons, and again, it almost looks like you could saddle up 2 cars in those little spots there that sulfur has along the east and the west side. And so sodium will lose an electron each, okay? And sulfur will pick up 2 electrons. Notice that, again, we have a neutral formula unit here because we have +1 and plus another one that's +2 plus -2 it's a wash again. And the last one I want to show you is joining magnesium with chlorine. Okay, and magnesium, if you look for it on your periodic table, you're going to need a periodic table handy, because you're going to find it in 2A, so it's a +2 charge. Chlorine, of course, is 7A. It's a -1 charge. And so actually, in order to make it neutral, okay, we have to have 2 of these -1s to counteract that 1, 2+. Okay, so it's neutral. I'm going to show you this method. Some of you, I know your book uses, I call it the crisscross method. So I'll kind of show you how we get MgCl2 if we want to combine magnesium and chlorine. All right, so I think this is back to what you have. So notice that when we wrote magnesium chloride, we didn't do the 2+ or the -1 for the magnesium and the chlorine. We don't show the charges on the formulas, right? And we write the cations first for ionic compounds. So one of the things you're going to want to be able to do is I give you a formula, and you're going to need to dissect the formula as to what kind of decompose the formula, what the name is. Always look for the positive charge, the cation first, and then the anion. That should help you. Okay. If there's more than one of those polyatomic ions like nitrate, NO3 negative, or sulfate, SO4, 2 negative, if you need more than one, I'll show you how this works, and we actually did an example in class. You have to put it in parentheses, and outside the parentheses you put the number, how many you need. All right, so here's where, actually this is in your notes too, but I have a few slides where I'd like you to go ahead and fill them out right quick. Make sure we're all on the same page. You might need... What is the formula that came from? Guess you don't have this one. Maybe you have the next one. All right. So let's talk about crisscross. First off, you guys okay with the K plus and the Cl minus? Okay? You know where those came from. So the crisscross to get the neutral formula unit looks like this. Okay? And I heard Robert say it just the other day, just yesterday. So if this is a plus or a plus 1, and this is a plus or, excuse me, this is a minus or a minus 1, what you do is the number of potassiums you need is the number on the charge of the chlorine, and the number of chlorines that you need is the number on the charge of the cation. So that's why we would write this as K1 Cl1. Okay. All right. Are you okay with this? If I ask you to, I want you to go to your box of cations and choose aluminum. You guys know it's aluminum plus 3 because it's in the 3A column. And I want you to combine it with sulfur. And sulfur, since sulfur's 6A, it'll pick up 2 electrons. So sulfur is a minus 2 anion. So if we crisscross, notice how that goes. Okay, we need 3 sulfurs and we need 2 aluminums. Okay, and so the formula for that is Al2S3. Works pretty good. Okay, crisscross here in your mind. What do you think? How many irons do we need?
3.
1 iron. Very good. How many bromines do we need?
3.
Perfect.
Edinburgh.
Yes. Now, you wouldn't know silver if you've looked for it. It's a group B element, and we're going to talk about silver in part 2 in here. So just trust me, it's a plus 1. Oxygen, we should know, it's a 6A element. So how many silvers do we need? 2. Very good. How many oxygens? 1. You got it. Okay. All right. So before I turn you loose for part 1, we're getting close. Not only do you need to crisscross and make the neutral formula unit, but you need to be able to name the thing. And just like it's written cation and anion, so also you name it cation and anion. So it's kind of nice. First name, last name. Okay. So the cation part, actually we're going to have to spend a little bit of time on that in part 2. Okay, but for now in part 1, right quick, for these ionic compounds in part 1, the name of the cation is going to be the name of the element. So sodium chloride, Na is just sodium, right? So we'll see how that goes. Okay, and that's because in part 1, they're going to be the charges that you can hang your hat on. These are all going to be 1A metals, 2A metals, or 3A metals for part 1. So you just use their name. In part 2, we're going to be talking more about these. Remember I said silver, right? Silver, I told you a minute ago, is a transition element. It's a plus 1. There are 3 transition elements, 3 transition metals that we always know what they are. And that's silver, and then the plus 1, and the other 2 are plus 2. Zinc plus 2 and cadmium plus 2. Okay? And I'll tell you what's significant about that in a minute. Okay, so part 1, we're almost ready to go. The other thing about part 1 is I need you to be able to name the last name, like table salt, sodium chloride. It's not sodium chlorine, right? So just like chloride, we basically drop, if it's a monatomic ion like chlorine, like Cl-1, we drop the INE and replace it with IDE. Now you're going to hear me enunciate IDE, and you're like, how rude is that? But actually there's, some of you know, a suffix called ITE, and it's like so frustrating. So ide and ite are 2 totally different things.
And ATE.
Yeah, and that's still part 3, and I do that on purpose. Okay, so I think, did I not do this? Let's see. Which name's on the anions? Thank goodness. All right, so yes, you do have this. So why don't you take a stab, and I'm going to go ahead and show these in a minute. This will help you with part 1. So the little box in the upper left-hand corner, that's what is being projected there. And that's what you should be able to fill in. So those are all monatomic anions. So they're non-metals, picked up electrons, and lop off the end of the name and replace it with ID as in dog E. Some of them are easier than others. Okay, now I mentioned there are 3 sections, and here are the 3 sections I was talking about. Okay, this is section 1. So I'll give you maybe, I don't know, 10 minutes or so. People work at different speeds, but I want to kind of show you what I'm after on this first page. I mentioned I do not advise working ahead. I really don't. And honestly, what you're going to see for this lab is, although I look at your answers, I don't look very closely. So I really hate to send you home with wrong answers, but it could happen, especially if you work ahead. And I'm just going to send you home anyway. But for this section, these are all the cations that are in 1A, 2A, or 3A. And these are all the anions that are just what you did the ides for kind of a minute ago. So you need to, on the top part, basically there will always be 2 columns. Let's pick on C for a minute. So the first column is the crisscrossing. So so how many aluminums do I need to combine aluminum with chlorine? 1, I agree. Now sometimes students will say, do I put that 1 or not? If you want to put that 1, you can. I'm totally good with that. Usually it's not. And then how many chlorines do we need? 3. Does that make sense to folks? Then the other thing I need you to do next to that is get, what's its first name? Aluminum. Aluminum chloride. Yes. So that's what you'll do on the first part. Let's take a look at the bottom part. Now on all of these are very kind of similar format. Down here at the bottom, let's pick on E. How's that? Okay, so what you need to do right next to E is write the component ions. So what's calcium? Ca 2 plus. Very good. Phosphide? No. What do you think?
P3 minus.
P3 minus. All right. So how many calciums do you need? 3. And how many phosphoruses do you need? 2. Okay, so that's that one. So like I said, you can work together, work on your own, but that's kind of what I'm after there. I guess sometimes I would put a comma there. Let's look at C right quick. C was a tricky one, right? Yeah, but let me tell you why. You guys, so what if I write barium, what sort of charge does it form?
Ba2 plus.
Right, very good. And oxygen?
O2 minus.
Right, very good. So, so here's the deal. If I crisscross, what do I get?
Technically nothing.
If I crisscross, I get Ba2O2. Here's the deal. If you ever get in that situation, we're not done yet. Because you can, if you ever get a situation where you have these whole numbers, these subscripts, that you can divide by another whole number to reduce it, you have to do that. So I think it was like Carmen was saying, the real formula for barium oxide is BaO, okay? So you can crisscross, but keep a lookout for that.
So only if they're like the same numbers then?
Right, if they're the same numbers, or if you had something that was a 4 and a 2.
I was going to say, like, what if it's like 4 and 2, then you can just do 1 and 2.
Right, very good. Yep, you got it. All right, so let's bump it up a notch and take a look at your slides one more time. Okay. All right. So here's the deal. The second section takes it up a notch in that those metals, the cations, are not 1A, 2A, or necessarily 3A. The problem is if the metal is not a 1A, 2A, or 3A, you don't know for sure if it's going to form a +1, +2, or +3. You know what I'm saying? Okay. So we're going to stick with actually the stock naming way. And let me show you. If you guys should have something in there that looks like this, a document that looks like this. Okay. You guys all find that? So this is to say, for instance, if we have a metal, and we talked about this in lecture, didn't we? We said that iron can form a +2 or a +3. And let's just say your cation is this one, okay? It's the +2. You can't just call it iron, okay? You're going to have to, in the first name of the compound that has that iron +2, you're going to have to call it iron, then Roman numerals in parentheses 2. That's its first name. Why? Because there's two forms. And so, kind of to catch everything, all of the B elements, you have to use the Roman numeral to indicate what charge it is. The Roman numeral here to indicate the charge. So let's pick on copper, okay, down here. Copper can be a +1 or a +2. Yeah, okay, they can both form ionic compounds. If it's a copper +1, in your name, you're going to have to go ahead and say it's 1 in Roman numerals. That's its charge. That's not how many of them you have. That's its charge, okay? And notice that, and actually our daughter's taking chemistry in high school right now, and they're using the common names, but we're going to use the stock names.
Aww, I want to use the cooler names.
So,
Coolers.
I don't know if they're necessarily the cooler. I think they're kind of silly, actually.
Coolers, so
I think they're kind of dumb. All right, so that's what we're going to do. Now, there are 3 exceptions, and I mentioned them already. Now, if you find silver, zinc, and cadmium, go ahead and find them. Find them on the periodic table. Where are they in the periodic table? Transition, yeah, that's right. They're definitely transition elements. They're right near each other. They kind of form a backwards L, okay? Actually, those 3, if those are your metal, you don't use a Roman numeral, and I'm kind of apologetic, because they only have one form. Silver's always 1, +1, and the other 2 are +2. Cadmium +2, zinc +2. So that's one of your crosses to bear. That's one of the things you have to figure out, is that when you give the first name, now this would just be in the naming part, whether you use Roman numerals or not. If your metal is 1A, 2A, 3A, or if your metal is these 3 transition elements, silver, zinc, or cadmium, you do not use Roman numerals, okay? Do not use them. That's what this says, okay? Anywhere else you need to use them.
So
all right.
You can just say silver or cadmium.
Right,
Yeah.
right. So actually, here you have go ahead and don't do that last one, but you have actually, on the sheet I gave you, you have access to these now. So go ahead next to calcium. If calcium +2 was your cation, what would the first name of your of that compound be with that cation? If potassium, and if you're like me, you have to find them on the periodic table. So the big thing here is, do you use Roman numerals or not? Use Roman numerals? Question mark?
For calcium, I believe no.
So go ahead and do those, and I'll go ahead and show you here in a minute. But to me, you need a periodic table. What's that?
You do use Roman numerals on calcium?
No, you
I
do
didn't
not.
think so. Well, you circled use Roman numerals, so.
Well,
it's
then I said a question
okay.
mark for everything. Yeah,
Alright.
yeah. I use Roman numerals, question mark. And see, to me, I'm not necessarily good about knowing if they're a metal or not. I kind of admitted that in class. So I have a periodic table handy. What I run into is on your test, I think these are like worth 1 point. If you use Roman numerals wrong, like you were not supposed to use Roman numerals, like if you put cadmium 2 here, that would be wrong. Or if over here, if you just put lead and it was really lead 2 or lead 4. Okay. So any questions about that? All right, I think that's okay. I think you guys are fine with. Okay. All right. So now go ahead and let's pick up the second page. Of course, the second page looks like this. Okay. So I think it's kind of, I don't think I need to do an example one. I think you're okay. So just go ahead for that part 2 and just be careful. Next to each one of them, you need to write 2 things. In the first part up here, you need to crisscross, write the neutral formula unit, then give its name. And the bottom of that page, you're given the name. You need to break it apart. For this second part, break it apart. Should we do one?
Yeah, let's do some.
Okay. Let's do an example for each. Let's start down here.
Can you tell us what element NH is?
NH4 is ammonium. NH4 plus. So, yep. Yeah, and that's part 3. So it kind of snuck in there. So, yeah, let's do a couple. Oh, right off the bat, let's do D. Let's do D. I was going to say, because D's one of those where we're going to crisscross, and you're going to get 2's, right? Okay. So how many, I would actually write it like, or we could either go straight for the, do you see where we could write CUS as the neutral formula unit? Does that make sense? Because they're both the same. And if we have one of each, they cancel each other out. If we crisscross, we would have gotten Cu2S2, and then we would have had to reduce it. Good. Okay, so what's the first name of this one? What's the first name? Copper 2. Yeah, you can't just put 2, or can't just put copper. Copper 2. And feel free to find it in the transition elements, transition metals. What's the last name? Sulfide, exactly. Sulfide. Did I go English on us? Sulfide is either way. Same thing. All right. Let's do one at the bottom. Now, how do I say this? On your test, I would write the component ions, just like you're supposed to do for this. On your test, I'm going to do both of these. I'm going to give you the formula and ask you to name it, like we just did with copper 2 sulfide. And I'm also going to give you the name and ask you to write the formula. So I would always write the component ions next to it. So let's pick on, excuse me, how about that top one up there? Let's go with A. Okay, so the component ions, what's the zinc part? The symbol for the element zinc is that. What's the charge? Right. I always have to get it mixed up with silver. Very good, you got it. Phosphide, of course, phosphorus is P, and the phosphide anion has what charge? Very good, 3 minus, perfect. So if we crisscross, what's the last thing we need to do? How many zincs do we need? Very good, 3. And always make sure, this is a struggle for students, always make sure when you're writing the formula, think of water. When we write H2O, it's always H subscript 2O. So that needs to be a subscript, very good. And then how many phosphoruses do we need? 2. Excellent. Okay, so I'll give you a little bit of time to knock those out. And I'm going to give you the answer key for all 3 sections before when you go to leave. It's kind of like Emerald would say, you know, kick it up a notch, that sort of thing, cooking, right? Okay, I think I've got some slides on that. Okay. So I've got a sheet. Can you find this sheet right here? Let's see. Everybody find that sheet? Okay. It's kind of loosely like, how do I say, well, it's got some of the stuff we've talked about it, but then it's got ions like nitrate that have, let's just find nitrate. So you think nitrate, you think nitrogen, right? So actually, if you find the nitrogen box, there is the nitrate there. And the thing about nitrate, you can see it's charged with a -1. So basically, the formula for nitrate you're going to want to know, okay? Everything on this chart you're going to want to know. Some of it is the stuff we've talked about. Like we talked about, you know, fluorine, chlorine, bromine. We talked about oxide, sulfide, that sort of thing. But nitrate is a polyatomic ion. It's got, what, 4 atoms? So it has a middle nitrogen atom. And actually, next week we're going to be drawing these structures. So NO3 looks like this. Okay? Where those solid lines, actually those are where electrons are shared. Those are covalent bonds. In order to show that it is an ion on our structures next week, we're going to do that. Okay, so that's NO3 -1. It's not a full Lewis structure, but we'll talk more about that later. So if you would, if you have this at the bottom, I want you to write 2 more. And actually, the first slide says these. Do you see these are all negatively charged? The title says, I think, anions. But there are 2 cations, okay, that are polyatomic cations. I want you to know one of them, I think, like Aaron was asking about, is NH4+. You're going to want to know the name of that is ammonium. Ammonium. Not to be confused with ammonia. I hate that those are so similar. Without the M on the end, ammonia is NH3 and it's a neutral molecule. Ammonium has picked up a hydrogen instead of NH3, it's NH4 and it's got a +1 charge. So ammonium cation. The other one is, and it's my least favorite, but okay, it's Hg2, so subscript 2, there's 2 of them, and it runs around with a +2 charge. Okay, Hg2, 2+. It's polyatomic. And the name of that is, and I'll try to tell you why this is, of course, Hg is the element mercury. So this is called mercury, Roman numeral in parentheses 1. You're like, really? It's a polyatomic ion. Here's what mercury 1 looks like. Let me choose blue. So there's 2 mercury atoms. There's 1 mercury atom covalently bond. Electrons are shared with another mercury atom, all right? All running around with a +2 charge. That's mercury 1. Okay? So you're going to want to know how that works. I kind of think we get the name mercury 1 here because each of those are kind of a 1+. I don't know. And unfortunately, or whatever, mercury, just the atom mercury, tends to lose 2 electrons and form a +2 cation. And so that's mercury 2. Okay, so let's take a look at the hints for polyatomic ions. There are some hints. You may have heard of some of these already. Okay, so here's my first hint. I told you to go ahead and on that sheet, I said jot down the positively charged polyatomic ions. Okay, ammonium is, and you're going to need to know ammonium has those 5 atoms and it's a +1. Okay. And most of those you actually could see, because you can kind of flip back and forth, have oxygen with them. These are exceptions. These don't have oxygen. So you're going to want to know cyanide is Cn with a -1 charge. Thiocyanate, SCN with a -1 charge. Iodine does this cool thing where 3 iodine atoms get together and run around with a -1 charge. Try iodide. Isn't that cool? Yeah, exactly. Try. We run into problems when we start doing the oxygenated polyions because they have different numbers of oxygen. Like, for instance, they're, and I'll show some examples. So these don't necessarily, I don't know what exceptions there. Okay, so here's your clue if you have like nitrogen. If you find nitrogen on there, find the little box nitrogen, you're going to see actually there's nitrate, which that kind of rolls off our tongues, nitrate, NO3-1. There's also nitrite, NO2-1. And that's why you'll hear me, I'm almost sounding rude. I'm going, ite. You know, they're 2 different things. Now, the deal there is the one that, for in this case, nitrogen, the one that has less oxygen is the I Te. The one that has more oxygen, I always think of 8, it 8 more oxygen. Okay? It has more oxygen. Now for sulfur, okay, it's different. Like you have SO4, 2 minus sulfate, but you have SO3, 2 minus sulfite. So instead of 3 and 2, like nitrogen, it's 4 and 3, right? Okay. Now here they are. Here's the two I talked about, the pairs. For sulfur containing with oxygen, okay, nitrogen containing with oxygen. The cool thing about it, and actually it wasn't all that long ago till I finally like, oh, that's neat. Notice they have the same charge. Like the oxygenated sulfur polyatomic ions have a charge of -2, both sulfite and sulfate. Nitrite and nitrate. So you're going to want to memorize those. Memorize. Then we get to the halogens. What group are the halogens? 7. Yep. The halogens are 7. What's group 8? What's the name of them?
Pure noble gases?
Right. Noble gases are 8A. Halogen 7A. Exactly. Those 7A nonmetals tend to form what we say 4 different versions with oxygen. There in the middle we have chlorite. I'm just picking on chlorine, but fluorine and bromine and they all do it. Chlorite and chlorate, but we actually have 2 species that have even less than 2 oxygens and even more than 3 oxygens. So what we got to do is add a prefix with our suffix. Okay. So if you're hypothermic, you're like, you don't have much heat, okay? So actually we would add hypo to chlorite to get the ClO minus. Okay, so that's hypochlorite. Per means extra and above. So we add a per to chlorate to get perchlorate to get our 4 oxygens. And if you look at that sheet with the polyatomic ions, you can see what I mean by the halogens. They all have this set of 4. Okay, so it's hypoite, ite, 8, per 8. So hopefully that helps. And they're all -1. Isn't that great? That's kind of nice. So there are some elements that combine with oxygen, and sometimes we add in a hydrogen. So think of it as you're adding in a hydrogen, it's an H+, specifically H+1. So 2 things, well I guess 1 thing mostly, you're going to see its charge go down. But you also have to say it's the name hydrogen somewhere. You have to say hydrogen somewhere in its name. Okay, I'm going to show you some examples. Okay, so for instance, if you're adding hydrogen to something that's already got a -1 charge, it goes to neutral. Okay, if it has a -2, it goes to a -1. If it has a -3, it bumps up to -2. So it's like adding 1. And so here's some examples of that. There's that sulfite, SO3 2 minus. Notice why I enunciate it, because sulfide is the one atom, right? S2 minus. Sulfite is SO3 2 minus. But notice if we have add a hydrogen, now we have to say, it basically has a longer name. Now it's hydrogen sulfite or bisulfite. I take either one of those. And notice now it's not -2, it's -1. Sulfate does the same thing, hydrogen sulfate. Carbonate, hydrogen carbonate. And phosphate, check this out. Phosphate, you'll find it under phosphorus. And regular old phosphate is PO4 3 minus. You kick in a hydrogen, it goes from 3 minus to 2 minus. So this is hydrogen phosphate. This, by the way, this last one where you have 2 hydrogens, that's the only time where you get to use the word di. D-I. It's not a word, a prefix. That's the only time you can use di in naming stuff. So if you want to say only use di here, you can. Dihydrogen phosphate. In naming things for ionic compounds anyway. Okay, so I think, let's take a look at a couple examples and I'll turn you loose for that last section. How's that? Peachy. Anybody have a request? Which one you want to do? Let's do F. Okay, so this is section 3. We're going to pick on F. There's 2 pages, right? So on that first page, section 3, again, we're going to crisscross, make the neutral formula, and then we're going to name that thing. All right? And we're just going to build on what we've done. So if we crisscross, how many nickels do we need?
4.
Not 4. 1. I agree. Does everybody see that? Cool. If we crisscross, how many hydrogen sulfates do we need?
2.
2. I agree. So this actually is one of those deals where we need, since we need 2, you have to put it in parentheses. Remember that the charge does not show up in the formula. We know it's 2 minus, right? And you guys told me that, sorry, we know it's minus 1, sorry. You guys told me we need 2 of these. So to get 2 of these, I'm going to put a 2 right there. Okay? That red 1 with the nickel is optional. Are we good with that? Okay, from the component ions, we got the neutral formula. Now let's name it. What's the first name going to be?
Nickel.
Nickel. Do we use Roman numerals? Find nickel. How many people think we use Roman numerals? Did you find it, Cameron?
I found it. It's 28.
Oh, yep.
So Roman numerals? Yes. All right. And actually, that is exactly what I would do on your test. Take your time. You guys did better taking your time on this last test. Take your time. You got 2 hours in a few weeks when you take your test. All right, nickel 2. What's the last name? So we're naming this. We're naming HSO4. Hydrogen sulfate. Fate. Yeah. And you know, it's kind of not fair to, you'll be able to spend some time studying them. You're just now learning them. So hydrogen sulfate. Perfect.
Yes.
Any questions about that? Let's do one example of the next page. So the next page looks like this. Let's pick on, how about, let's do J. Okay, so we're going to pick on J, that iron 2 hydroxide. So yeah, the way we're going to get the cation is we're going to kind of read from left to right. So that's our cation, and this must be our anion. So kind of be thinking of that when you read it, right? Okay, so what's our component cation? Did I say iron 3 and iron 2? So it'd be Fe, and what's the charge?
2 plus.
2 plus. Very good.
I don't know why I said that. I was looking at I.
Okay, so I'll write a comma. What about the hydroxide part? What does that look like?
OH minus 1.
Perfect. Very good. Thank you. I'm liking that. So that's the component ions. Let's crisscross. Okay, I'm going to write Fe. How many Fe's do we need? We just need 1. Very good. And that 1 is optional. You got it. How many OHs do we need? 2. We do need 2 OHs. So here's an example where since I need 2 of these things, in order to get 2 of them, I have to nest this. And that's it. Iron 2 hydroxide.
Why do we have to do the parentheses on that one?
Because you need two OHs, so you need 2 of both of those compounds and make this. So it's the entire.
So if it has parentheses, if it has a, if you put the 2 in parentheses and
No, because the 2 is just for Fe.
Yeah.
Right. We need 2 hydroxides because Fe is 2 plus. So you crisscross it, you only need 1 Fe. So we need 2 OHs because you crisscross it, so the OH is like 16. Alright.
It's a lot of people don't. That parentheses is a tough one for the hydroxide. One of the things I think about is if I were to do this OH2, what is that? It's water, isn't it? Like H2O, OH2. Yeah, so that doesn't work. Okay, so let me say before I turn you loose, when you're done, I'm going to kind of come around. I'll be here. But I'm going to hand out a few things. One of the things I'm going to hand out are these, and you can use them for scratch paper if you don't use them for what I intended. But these actually you can turn into flashcards. And so, of course, you cut along this main line, you cut along here, and you fold them over, and then they end up looking like this, where you can quiz yourself on the name and the species. So that's a thought. The other thing I'm going to give you is the answer key, and the third thing I'm going to give you is a paper that looks like this. I stapled it, even though it's a single page. But anyway, it's front and back, and this will be due on Monday. Okay? All right. That's it.